Hi everyone, it's Miss Costa here, and in this video we're going to go through some of the topics that could come up on Wednesday the 10th of June for the Edexcel Higher Paper 3. Okay, so for the first question we're dealing with the frequency polygon. Now I'm showing a table that shows the heights and information about the heights of 90 students, and the first part of the question is asking you to find the class interval that contains the median. Now the class interval is going to be one of these. The class interval is essentially saying between 130 and 140 centimeters height, and then you've got between 140 and 150 centimeters height, and so forth. So I need to find the class interval that contains the median. Well, there are 90 students in total, and the median is the halfway point or the halfway value. Half of 90 is 45. So therefore, I need to figure out where the 45th student is, in which interval they are. And I use cumulative frequency to do that. So the first 8 students are between 130 and 140 centimeters. Then another 13 students are between 140 and 150. So far we've got 8, and 8 plus 13 is 21. So the first 21 students are up to 150 centimeters in height. Then I'm going to add 29. So 21 plus 29 is 50. So the first 50 students are up to a height of 160, and I'm looking for where the 45th student is. Now 45 is going to be higher than 21, so it's going to need to be in this class interval, because up to 21 students height of 150 centimeters, but below 50 is where the 45th student is. So the 45th student's height must be between 150 and 60. So we just write out the class interval as it is. Then I'm asked to draw a frequency polygon for the information. Now the way that we sketch a frequency polygon is by figuring out what the midpoint of the class interval is. So we're always going to use the midpoint. So here it will be 135, here it would be 145, 155, 165, 175. So my x-axis is going to be the midpoint of each class interval, and the frequency is going to be whatever it says in the table. So my first point is going to be 135, 8. So I just plot that. 135, I figure out that the scale is going up in 1, so that would be 5, 6, 7, 8. Then I've got 145 and 13, so 10, 11, 12, 13, 155 and 29, so 29 would be up here, 165 and 30, so up here, and then 175 and 10. Now that you've plotted the coordinates with a frequency polygon, what we need to do is join them up as straight line segments. So you don't start from 0, because as you can see the frequency polygon starts from 130. So we start from our first point, which is the midpoint. So over here we join our frequency polygon with straight line segments, and then that is it. Okay, so that is how we do a frequency polygon. Okay, so in this question I'm dealing with Venn diagrams, and I am told that the universal set is all of the odd numbers that are less than 20. So this little sign here, that represents the universal set, which means everything that can exist inside the Venn diagram. So a Venn diagram is as though like we shrink the world into possibilities, and inside this Venn diagram, inside this world, the only things that can exist are the odd numbers less than 20. So let's start by writing out what the universal set would be. So it's the odd numbers less than 20. So that would be 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. And then for set A, what can exist within set A, which is this circle here, are the prime numbers. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. And then for set B, I've got a sequence, so 2n plus 1. So really quickly, I might try and work that out. So 2n plus 1, what would that be? Well, the first term would be 2 times 1, which is 2, plus 1, which is 3. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 6, plus 1 is 7. So we should realise that that is just going up in twos. So that's going to be 3, 5, 7, 9, 11, 13, 15, 17, 19. Okay, so we've listed what the possibilities for each set are. And now what we want to do is find out what is going to be in the intersection. So this is anything that exists in set A and set B. This is why the two circles overlap. So anything that overlaps goes inside the middle section. So anything that is in both set A and set B. So let's start by crossing them out. So 3 is in set A and B, so I'm going to write that. 5 is in both. 7 is in both. And actually, while I'm doing this, I could cross it out from the universal set as well, because I know that I've used those numbers. 11 is in both, so I'll write that out. 13 is in both. 15, nope, 17 and 19 is in both. Okay, so then what am I left with? Well, in set A, I'm left with 2, and that's it. 2. Oh, and also I don't actually have 2 because inside this universal set, the only things that could exist are the odd numbers that are less than 20. So that was a sneaky trick there and that caught me out. So 2 is obviously not an odd number. Even though it's a prime number, it's not an odd number, so it can't exist. So there's nothing that's in set A that is not also in set B. So then we look at what is left in set B. So I've got 9 and 15. And then I can cross that out over here. And the only number that's left out over, so anything that is not in A and not in B goes outside of the Venn diagram. So I'm going to put 1 over here. So that's how I'd complete that Venn diagram. And in total, to double check, how many numbers are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you know you've put the right numbers in. And then told that a number is chosen at random from the universal set. So how many numbers did I just say there were in the universal set? There are 10. So therefore the probability is going to be out of 10. And it says, what is the probability that the number is in the set A, and then the little rainbow sign B. So real quick recap, if it looks like this, it's going to be asking for what is, see, it kind of looks like an N, so you could say it's A and B. So what is in A and in B, which means what is in the overlap. So that's the intersection bit. If it looks like this, so like a U, then that is saying what is in A or in B or in both. So that is essentially what appears in the whole little circle part of the Venn diagram. But it's asking me for the intersection of A and B. So how many numbers are in the intersection? 1, 2, 3, 4, 5, 6, 7. So the probability that the number is in that set is 7 out of 10. Okay, so in this question, we've got a quadratic graph, but the first part is to fill in and complete a table of values. Now, this is a calculator paper, so it should be quite straightforward, but I'd still recommend always starting from the right, as that is where your positive numbers are. So it says complete the table of values for y equals x squared plus x minus 3. These are your x values, and you do them one by one. So here we've got 3 squared plus 3 minus 3. You're just substituting this value into the equation of the line. So that become 9 plus 3 minus 3. That would cancel, so that would just be 9. Then we've got 2. So we've got 2 squared plus 2 minus 3. So 4 plus 2 is 6. 6 minus 3 is minus 3. Then we've got 0. Well, 0 plus 0 minus 3 is just minus 3. And then we've got negative 3. Anything negative squared is going to be positive, so that's going to be 9 plus minus 3 minus 3, which would become 9 minus 6, which is positive 3. So that's how we'd fill out our table of values. And I'm just going to fill these in for the next page. So 3 minus 3 minus 3, 9. So 3 minus 3. Is it minus 3? Or have I done something wrong? No, it's not minus 3. Sorry. So this is how it's really good to spot your own working. So 2 squared is 4. 4 plus 2 is 6. 6 minus 3 is positive 3. Don't know why I put minus 3. Anyway, that would be 3 and 9. So now you've got your table of values. All you're going to do is plot the graph. It's a quadratic graph, and every quadratic graph should look like this, unless it's a negative, in which case it's going to look like that. So you're going to know instantly if you've worked out one of the coordinates wrong, because it's not going to be a smooth line. If your graph ends up looking something like this, then you're like, okay, clearly this point must be wrong. So you can go back and correct it. So let's start plotting. We've got minus 3 and 3, and let's look at the scales. Always look at the scales. So this is 5, which means that you've got 10 squares making up 5, which means that 1 is going to be 2 squares. So that's going to be 1, 2, 3, 4. So minus 3, 3 is going to be here. Then we've got minus 2, minus 1. So again, you can do, you can just scribble on your axes, that's minus 2. So minus 2, minus 1 would be here. Then we've got minus 1, minus 3. And then we've got 0, minus 3. So let's just scrub out these scribbles. 0 minus 3 would be 1, 2, 3. We've got 1, minus 1. And then we've got 2, 3. So 1, 2, 3. And then finally we've got 3, 9. So that would be over there. So as you can see, it's like a smooth, it looks like a curve. And then we're going to just join it up as smoothly as we can. Freehand, so not with a ruler, we're just going to join it together like a curve. So that is my graph. And then it says use the graph to estimate a solution for x squared plus x minus 3, which is this graph. This is the graph of y equals x squared plus x minus 3. And you need to work out an estimate, a solution for when that graph, the y value equals 2. So what we do is we draw the line y equals 2. So that's going to be over here. And it doesn't look great on this because that's roughly 2. You'll do it a lot better on your sheets. So that's 2. You draw that line. And what we do is we write down the coordinates where the line y equals 2 meets the graph. So that would be minus 2.5, 2.6. So that would be when x is minus 2.7. There's you're always going to have like a little allowance of accuracy. And then over here, that's going to be 1.5, 6, 7, 8. And when x is 1.8. So something along those lines. As long as you've used your graph and you've shown your working lines, you'll get the marks. But that's how you estimate a solution. You make it equal to the line with this equation. Okay, so in this question, I'm told that I've been given information about the time taken in seconds by 27 students to run 100 meters. And I need to work out an estimate for the mean time taken to run the 100 meters. So whenever I'm estimating the mean from a grouped frequency table, and a grouped frequency table is where you see these intervals where it's like the time is between 5 and 10 seconds, what we have to do is we have to use the midpoint. So sometimes it's helpful to draw a midpoint column. Most people just know the midpoint anyway, so you choose what you want to do. The reason we use the midpoint is because the time taken could be anywhere between 5 and 10 seconds, and the midpoint is just a good average to use as we're estimating. That's why it's estimating the mean. So the midpoint here would be 7.5, the midpoint here would be 12.5, 17.5 and 22.5. Actually, I'm just going to write it like this because it looks better. So the way we work out the midpoint is by adding the two values together and dividing by 2 if they're tricky values. Otherwise, you could just be able to find the halfway point. So we get a new column, which would be our, so we do our midpoint times by frequency. So I do 8 times 7.5, which would be 60, 7 times 12.5, which is 87.5, 10 times 100, 17.5 would be 175, and then 2 times 22.5 would be 45. So you've got your new column here, which is your midpoint times frequency column. We're going to add those totals up. So when we add them up, that gives me 367.5. And I'm going to divide that by the total frequency. Now, I've been told either you can add your frequency column up again, or you've already been told what your frequency is, which is 27. So I'd do 367.5 divided by 27, which gives me 13.611111. And it says give your answer correct to 3 significant figures. So I'm just going to do 13.6. Okay, and this question, we've got metric conversions, and these kinds of questions always really surprisingly catch people out. So think very, very carefully if they give you a question like this. So I'm asked to write 45 centimeters cubed to millimeters cubed. Now, some of you might know your metric conversions off by heart, but if you don't, a really good method is to actually just try and visualize what's going on. So I'm trying to turn centimeters cubed into millimeters cubed. So let's think, like, I know that 1 centimeter is 10 millimeters. So the common misconception is that people are just like, okay, I'm just going to times by 10. But that's not what's actually happening, because we're dealing with volume. So if we just think about what happens when we've got 1 centimeter cubed, you've got 1 by 1 by 1, and that's why it's 1 centimeter cubed. But if I convert my centimeters to millimeters, that same 1 centimeter cubed, each side is going to be 10 millimeters long. So if I have a cube that has side length 10 millimeters, the volume of that cube is going to be 10 times 10 times 10, which is 1,000 millimeters cubed. So 1 centimeter cubed is actually 1,000 millimeters cubed. Therefore, to turn centimeters cubed to millimeters cubed, I need to multiply by 1,000. So 45 centimeters cubed to millimeters cubed is going to be 45,000 millimeters cubed. And you can do this with anything. So if you had to do, let's say, meters to centimeters, then, and you're doing, like, let's say meters squared, you do 1 meter by 1 meter is 100 centimeters by 100 centimeters. So 1 meter squared would be 1, 2, 3, 4 would be 10,000 centimeters squared. So just use that as a quick visualization to help you. Now, the next type of conversion could be changing speed. So I need to change a speed of 150 kilometers per hour to meters per second. So I've got 150 kilometers per hour, and I want to change it to meters per second. So we want to do this bit by bit. So I know that 1 kilometer is 1,000 meters. So the first part could be changing kilometers to meters. So I'm going to do 150 times by 1,000. To turn kilometers to meters, we multiply by 1,000. So that's going to be 150,000 meters per hour. Now, some of you might know how many seconds there are in an hour, but if we didn't, then we know that 1 hour is 60 minutes, and you know that in 1 minute there are 60 seconds. So therefore, 1 hour must be 3,600 seconds. So in 1 hour, the speed is travels, whatever it is it's traveling, is 150,000 meters per hour, and I know that 1 hour is 3,600 seconds. So therefore 150,000 meters is traveled in 3,600 seconds. So if I want to work out how much is traveled in 1 second, then what I can do is divide by 3,600. So 150,000 divided by 3,600 is 41.67. So that's going to be 41.67 meters per second. And the key is just do it bit by bit. So first change your kilometers to meters, and then think about changing your hours into seconds. Okay, next I've got a cumulative frequency graph. So I'm told that the table shows the marks that some students got in a test. I can always figure out what the total is because the cumulative frequency tells me what everything adds up to. So I know that there are 80 students involved. And I asked to plot cumulative frequency graph for this information. Now, unlike the frequency polygon where you plot against the midpoint, in a cumulative frequency graph, you plot against the end point. So for the first coordinate, it's going to be at 10, 10, because you plot the x value as the end point of the class interval, and then the y value is the cumulative frequency. So 10, 10, then you've got 20, 15, then we've got 30, 32, then we've got 40, 56, so 52, 46, then we've got 50 and 68, and then 60 and 80. And your cumulative frequency graph is always going to kind of look like this. Now this one starts from 0, so you're going to start it from 0, because essentially it's saying the marks were from 0 to 60. So we join it together with as smooth as a curve as we can, and that's my cumulative frequency graph plotted. Then I'm asked to find the median mark. So the median is the halfway value, and I'm always going to use the cumulative frequency, so the y-axis, to work this out. So the median mark is going to be the half, however, what your total frequency is, which is 80, the median is going to be the halfway point of that. So half of 80 is 40. So I'm going to go along the cumulative frequency, go along to 40, go to the graph, and then go down. And when I read that, that should give me about 32, 33. So the median mark would be 33. For the next part, I'm told that 25% of the students fail the test. Work out an estimate for the pass mark. So this is actually conveniently the lower quartile, but we're not dealing with box plots, so that doesn't matter too much. 25% of 80 is 20. So that's a quarter of the data. So what I'm going to look for is where the 20th on the cumulative frequency is. So on my cumulative frequency graph, I go to 20, which is 25% of the data, and I go down, and that gives me so 21, 2, 3, 4. So the 20% of the students, 25% of the students, sorry, got 24 marks or less. So I know that 25% of the students fail the test, 25% of students get 24 marks or less. So therefore, an estimate for the pass mark would be 25, because if they got 24, then they would have failed. So that's how we do a question like that. So 25%, we work out 25% of what the cumulative frequency is. 25% of 80 is 20, and then we go along and we read it from the graph. Okay, so here I have been given a garden formed of a right angle triangle and a circle sector. I'm told that triangle ABC has angle ABC is 90 degrees, which means it's a right angle triangle. And with any right angle triangle, I know automatically that I should be thinking Pythagoras or trigonometry. Then I've got the circle sector, which has centre C and radius CB. So if this is the centre and this is the radius, then I know that it's a quarter of a circle. So whatever the area of the circle is divided by 4 is going to give me that area. So I need to work out the area of the garden and give my answer correct to 3 significant figures. Okay, so how do I work out the area? First, I can start with the triangle. So to work out the triangle, you need to do the base times by the perpendicular height divided by 2. The perpendicular height is going to be whatever meets the base at a right angle. So that's going to be the line CB. It's a right angle triangle, so I know I can use Pythagoras, and I can start by labelling my sides. So A and B are your two shorter sides, so this could be A, this could be B, and C is the hypotenuse, and to identify which one must be C, it's going to be the side that is opposite to the right angle. So because I've got the hypotenuse, I'm trying to find a shorter side, so I'm going to do C squared take away A squared equals B squared. So that's going to be 15 squared take away 10 squared is going to be B squared. So 225 take away 100 is going to be B squared, and therefore B squared must be 125. So B is going to be the square root of 125. And if I type that into my calculator, I am told that B is 11.1803398875. So I know the length of B is that. So B is 11.18 and so forth. Now, to work out the area of the triangle, I'm going to have to do base times height divided by 2. So I'm going to do the base, which is 10, times by my answer in my calculator. It's just a quick way to save things. So instead of typing out the decimal, you just press the answer because it remembers the last thing that you've entered into it. So 10 times by my answer divided by 2 is going to give you 55.9. So the area of the triangle is 55.9. Well, 55.901 and so forth and so forth and so forth. So we can write that out somewhere. Let's write out the area of the triangle somewhere so we can save it for later. So area of triangle, remember you don't round until the very end. A common mistake people make is they round and then the answer is just a little bit off at the end. So write out everything that you see on your calculator. So that would be 55.9016994.375. Now we need to work out the area of the sector. So if it was a circle, the area of a circle is pi times radius squared. I figured out what the radius is because the radius is the same length as CB, which is 11.18. So we didn't write that full value out, but hopefully you did somewhere. So it should have been 11.1803398875. So that's my radius. So I'm going to do pi times 11.18 and write out the whole thing into my calculator squared. That would give me the area of a full circle, but it's a quarter circle, so I'm going to divide it by 4. Another thing you could have done actually is we know that CB squared, or the radius squared, is 125, so you could have used that if you couldn't be bothered to write it out. So we could do pi times by 125, because 11.18 squared is going to give you that, divided by 4, and 125 pi divided by 4 is 154.07646. So that's the area of this. Oh no, sorry, that should have been, it's because I worked, I don't want to use my calculator. So I worked it out, but now I'm copying out the wrong thing. Okay, so let's do it. So shift pi times by 125 is divided by 4 is 98.17. So let's rub this out. It's going to be 98.17. So this is 98.174777042. So you've got your area of your sector and your area of your triangle, and you're going to add them together. So that's going to be plus 55.9016994.375, which is going to give you a total area of 154.0764699. We don't need to worry about that because it says give it correct 3 significant figures. So the total area is going to be 154 centimeters squared. So a very, very small garden. I am assuming this is a miniature garden for a tiny little dollhouse. Okay, so here we've got an example of reverse percentages, and you use reverse percentages when you've been given like the sale value of something or a changed price and you want to work out the original amount. So I'm told that in a sale, everything is reduced by 15%, and Aidan buys a suit in the sale for £59.50. So if everything is reduced by 15% and its starting percent is always going to be 100 because a whole thing is 100%. So 100% take away 15% is 85%. So I know that the sale price is worth 85% of the original value. So I know that 85% is equal to £59.50. Now there are a few ways that we can do reverse percentages. The surefire fail-safe way is to work backwards. So I know that 85% is £59.50. Therefore 1% is going to be this divided by 85, which is £59.50 divided by 85, 0.7. So I know that 1% is 70 pence, or 0.7. I multiply that by 100 to get back to 100%. So I first divide by 85 to work out what 1% is, and then I times by 100 to work out what 100% is, and that is going to give me £70. If you want the quick way, then what we can do is divide by the multiplier, but that involves you knowing that you have to divide by 85. So you could have done £59.50 divided by 0.85, but I would recommend only doing that if you're really, really confident with reverse percentages. If not, I would use the first method. Okay, so here I've got some index laws. So for the first one, I'm told 2 to the power of n times 2 to the power of 31 over 2 to the power of 13 is 2 to the power of 11, and I need to find the value of n. So I'm going to need to know my laws of multiplying indices and my laws of division. So when I'm multiplying indices, if I had a to the power of 5 times by a to the power of 3, what I do is I add the indices together. So that would be a to the power of 8. And similarly, when I'm dividing, what I do is I subtract the indices. So hopefully this is just a recap of laws that you already know, and we're going to use this. So we know that 2 to the power of n times by 2 to the power of 31 is going to become 2 to the power of n plus 31, and that's going to be divided by 2 to the power of 13, and my answer is going to have to be 2 to the power of 11. So what do I do when I divide indices? Well, I subtract. So I know that n plus 31 take away 13 must equal to 11. Because this divided by this, just like if I had a to the power of 5 divided by a to the power of 3, I would do 5 take away 3. What I'm doing is this take away this. And now I've got kind of like a little equation. I can figure that out. So 31... I'm going to use a calculator just because it's been a long day. 31 take away 13 is 18. So n plus 18 equals 11. Therefore, I'm going to have to subtract 18 from both sides. 11 take away 18 is minus 7. So therefore, the value of n is negative 7. I can double check that to see if it works. So I know that 2 to the power 7 times 2 to the power 31 over 2 to the power 13 is going to simplify to 2 to the power, oh, sorry, it's minus 7. So minus 7 plus 31. Minus 7 plus 31 is 24. So that's going to give me 2 to the power of 24 divided by 2 to the power of 13. And 24 take away 13 is going to give me 2 to the power of 11. So that works. So slightly more difficult question than normal, but use all of the power laws that you know in order to work this out. So n should be negative 7, and I just showed you how to double check it. Next, we've got a similar thing. Write 27x to the power of 9 all to the power of 2/3 in the form axb, where a and b are integers integer just means a whole number. So a quick reminder, when we've got indices, let's say we've got 64 to the power of 2/3, you always do the root. The denominator is like what you're going to root it to. So it's normally going to be 2 for a square root or 3 for a cubed root. And then the numerator is what you do it to the power of. So what this actually means is the cubed root of 64, then put to the power of 2. Okay, so you first root it and then you do it to the power. So cubed root of 64 is 4, then so 4 squared is 16. So that's just an example of what we do. So we're doing this for 27. So let's do it in 2 parts. 27 to the power of 2/3 is going to be the cubed root of 27 to the power of 2. The cubed root of 27 is 3, so that's going to end up being 3 squared, which is 9. So I know the first part of my calculation is 9. And then I've got, let's get rid of this here, I've got x to the power of 9 to the power of 2/3. So with the law of brackets, what we do is we multiply the powers together. So that's going to be 9 over 1 times by 2 over 3. Remember, any number can be turned into a fraction by writing it over 1, which becomes 18 over 3, and 18 divided by 3 is 6. So that would become 9x to the power of 6. So A would be 9 and B would be 6 if they asked for the values of A and B. The last bit is factorise a squared minus 49. So this is just a quick cheeky little reminder about the, difference of two squares. So when you've got a square number, take away another square number, i.e. the difference between two square numbers, and you factorise it as the square of the first one plus the square of the second one, and the square of the first one plus minus the square of the second one. So the square root of a squared is going to be a. The square root of 49 is 7. So it's going to be a plus 7, a minus 7. And the reason we do that is because when we expand it back out, because it's difference of two squares, it would be a squared minus 7x plus 7x minus 49. These two terms always cancel out, and that's how we know that we can do that. So it's a nice little trick. Difference of two squares, look out for it. If you've got a square number, take away another square number. Okay, so here we've got an equation of a line and some perpendicular line knowledge that we're going to need. Remember, the equation of any line is y equals mx plus c. That's the form that you want to get it in. So if it's 6y, then you're going to want to divide by 6. And m represents the gradient of the line. So m is always the coefficient of x, the number attached to the x. And c represents the y-intercept, which is where it crosses the y-axis. So I'm told the straight line L has the equation 6y equals 5x plus 8. Okay, if I'm given a line, I'm not even going to read the rest of the question. The first thing I'm going to think to myself is I want to get that in its proper form, y equals mx plus c. So 6y equals 5x plus 8. I want to divide everything by 6 so that I get it into its form, y equals. So that's going to be y equals 5/6 x plus 8 over 6. And this is the equation of line L. The point A has coordinates 4, minus 7. I need to then find an equation of the straight line that is perpendicular to L and passes through A. So what do I know about perpendicular lines? Well, there's a really special thing that happens. Perpendicular lines, all of their gradients, if two lines are perpendicular, their gradients are going to multiply to make -1, i.e. they're going to be the negative reciprocal of one another. All that means is, let's say you had a gradient of 5, the negative reciprocal would be -1 over 5. If you had a fractional thing like I do here, 5/6, the negative reciprocal, you flip the fraction and stick a negative sign onto it. So perpendicular lines, then they have their gradients are always going to be negative reciprocals of each other. So that's line L. My line, and they haven't actually told me what my line is going to be y equals, and I just told you that if L has the gradient of 5/6, my line is going to have the negative reciprocal, which would be -6 over 5. So the gradient is going to be -6 5x plus c. I don't know what c is yet, but it's always good to get it into this form. So that's the beginning of finding out what my line is. Now I've been given another piece of information, which is that the point A has coordinates 4, -7, and I need to figure out the equation of the line that goes through point A. So therefore, this line, my line, is going to go through point A, which is 4, 7, -7, which means I know one of the coordinates on my line. So when x is 4, y is -7. I can substitute that into my line to figure out what c must be. So y is -7, I'll substitute that here, is -6/5 times by 4. And that's going to tell me what c is. So -7 is -24/5 x. Sorry, no, just -24/5 plus c. So therefore, you've got a calculator, c is going to be -7 plus 24/5. And that is going to give me -7 plus 24/5 is -11/5. So that's it. So C is what? -11/5. Let me just double check that I did that. -7 plus 24/5. Yeah, -11/5. So C is -11/5. So I have the equation of that line. Y is going to be -6/5 x -11/5. So remember, whenever we're dealing with any of these kinds of questions, always get the equation of the line in its form, y equals mx plus c. And then if they're perpendicular lines, their gradients will times to make -1. If they're parallel, their gradient's going to be equal. And then if you're given any coordinate, you can substitute that into the equation of the line once you found out what the gradient is, to figure out what the c value would be, and then you have your equation. Okay, so next I have got a changing a subject, slightly tricky one, but we just use the information that we know. And if it's something like algebra, you know that you can manipulate it as many times as you want, so move things from one side to the other as much as you want. So let's give it a go. So I need to make x the subject of this formula. So first thing I'm going to want to do is make sure that I eliminate the denominator. So multiply both sides by 7 minus 2x. So that would become y 7 minus 2x equals 3 2x plus 1. And then I don't have a fraction. It makes my life a lot easier. Now I've got brackets. I'm going to want to expand them. So I'll be left with 7y minus 2xy equals 6x plus 3. And this is where it gets a little bit trickier, because we've got a term that has x and y in it. But whenever we're doing anything like this, we want to make x the subject. So what we want to do is bring all of the x terms to the same side. So I'm just going to do that. I'm going to remain calm and just do what I need to get all of the x coordinates onto the same side. So 7y is 6x plus 2xy, and then I've still got the plus 3 here. What I can do next is get rid of that 3. So I've got 7y minus 3 equals 6x plus 2xy. So now I have all of my x terms on the same side. What I can do is factorize. So that's the key to take the next step. I'm going to factorize. So 7y minus 3, I'm going to take the x out, because if I factorize, then I have only one lot of x. So x times by 6 gives me 6x, and x times by 2y gives me 2xy. So now I've got it like this. I've got this bit here, which can count as one term because it's in brackets. So I can just divide both sides by what's inside the bracket. And then I'm left with 7y minus 3 over 6 plus 2y equals x. So I've made x the subject, and that is how you'd do a slightly tricky one like that. Okay, so here I am given a shape, triangle T, which is drawn on a grid, and I'm asked to enlarge triangle T by scale factor -2 through the point -3 minus 2. So point -3 minus 2 is over here, and I'm enlarging by -2. So the best way to do this is using vectors. So what I do is I'll label this A, B, C. I've got 3 points, and what I want to do is think, okay, from my center of enlargement, how do I get to each point? So to get to point A, I'm going across 1, so -1 on the x-axis and -2 on the y-axis. I'm going to times this by -2, and that's going to give me +1 and +4. So that means from my center of enlargement, I'm going to go across 1 on the x-axis and up 4 on the y-axis. So that's where my point A is going to be. I then do the same for point B. So I go -1 and -3 along the x-axis and -2 along the y-axis. I times that by -2. That gives me +6 and +4. So I'm going to do the same. I go across 6 on the x-axis. So 1. Oh, sorry, this should have been +2. So this should actually be over here. Let's ignore that minor slip up. So I'm going to go 6 on my x-axis. So 1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4. So that's where that point is going to be. And then for point C, I'm going to go 1, 2, 3. So -3 on the x-axis and up 1 on the y-axis. So times that by -2, and that would give me +6 and -2. So I'm going to go 1, 2, 3, 4, 5, 6 on the x-axis and -2 on the y-axis. And then I'm going to join my shape up, and that is going to be my enlargement. So a negative enlargement basically reverses the direction, and that's why the best way to do it is through your column vectors. You times that by your scale factor, and that tells you what vector you need to move through to enlarge the shape. Okay, so here I am given a circle with a cyclic quadrilateral in it. So a cyclic quadrilateral, all that means is it's a quadrilateral, 4-sided shape inside a circle. And what I should know about that from my circle theorems is that opposite angles in a cyclic quadrilateral sum to 180 degrees. So that's the piece of information that I'm going to want to know. ABC and EDC are straight lines, and angle DBC is 70 degrees. So the first thing I can do is work out that this angle here must be 110, because angles on a straight line sum to 180. Using cyclic quadrilaterals, I know that this angle here therefore must be 70 degrees, because opposite angles in a cyclic quadrilateral sum to 180. I'm then told that the size of angle EAB, so this angle here, to the size of angle BCD, so this angle here, is in the ratio 3:2. So I've got this triangle EAC. I know that this angle here is 70, and this angle here is going to be 3 lots, and this is going to be 2 lots. So I can just write it in algebra just to make my life easier. I could have also subtracted from 180 and then split 110 into the ratio 3:2. You do whichever method works best for you, but this method also works. So I know that 70 plus 5x must equal 180, therefore 5x must equal 110, and x must equal 22 degrees. So if x is 22 degrees, I need to work out the size of the angle BCD, which is this angle here, which has a value of 2x. So therefore BCD is 44 degrees. Okay, so here I have got a speed, distance, time question with bounds thrown in. So I'm told a train travelled from London to Bournemouth in 130 minutes, correct to the nearest 5 minutes. Angelo finds out that the distance of the journey is 149 kilometres long. He assumes that the track has been measured to the nearest kilometre. What is the average speed of the train? So I know that speed equals distance over time, and I'm always going to want to have my time in terms of hours. So the first thing I could do is turn my minutes into hours, but first let's work out our bounds. So 130 minutes to the nearest 5 minutes. What I do is, okay, if it was 5 minutes above, it would be 135. If it was 5 minutes below, it would be 125. So to find the upper and the lower bound, I work out the midpoint of that. So the midpoint of this is going to be 127.5. 132.5 minutes, and this would be 132.5 minutes. Now to turn minutes into hours, I divide by 60. So I'm going to do this divided by 60, and that's going to tell me what my upper bound of time and lower bound of time is. So the lower bound is going to be 127.5 divided by 60, which is 2.125 hours. And the upper bound of time is going to be 132.5 divided by 60, which is not as nice a decimal, it's 2.2083 recurring hours. So that's my upper bound and lower bound for the time. Now, I know that the distance is 149 kilometers long, assumed to the nearest kilometer. So again, I add 1 kilometer above, 1 kilometer below, and to find the upper and the lower bound, I'm going to do the midpoint. So that would be 148.5 for the lower bound and 149.5 for the lower bound. So I need to work out what the average speed is. Remember that speed equals distance over time. So I'm going to have to do that for all of my values. So the speed is going to be distance 2.125 over the lower bound of time, 148.5, or 2.125 over the upper bound of time, 149.5. Or if I use my, speed equals distance divided by time. This is why it's good to just double check your answers. So the distance, let's start with the lower bound, would be 148.5 divided by 2.125, or 148.5 divided by 2.2083. Or I could use my upper bound of distance, so that would be 149.5 divided by my 2.125, and 149.5 divided by 2.2083. This allows me to get every possible combination for the speed of the train. So let's just type those all into my calculator. 148.5 divided by 2.125 is, well, where should I write this? Let's write this here. So that would be 69.88235294. Let's do the next one, 148.5 divided by 2.2083 recurring is going to be 67.24528302. Then I do 149.5 divided by 2.125, which is 70.35294118, and 149.5 divided by 2.2083 recurring, which is going to give me 67.698111321. So it tells me, so remember, the first thing, the really, really important thing with bounds questions is that you always work out the upper bound and the lower bound of the original values. Some people work it out and then work out the upper bound and lower bound of the answer. That's not what you need to do. Whatever they've given you, you work out the upper and the lower bound of this, upper and lower bound of that, and then work out all of the calculations. So the average speed of the train, well, I know that the speed, the lowest speed was 67.25 kilometers per hour, and the highest speed was 70.35 kilometers per hour. So it says you must show how you got your answer. You've got all four of your values here. So you could say, as long as you've got your working here, we want to think what everything could round to so that it rounds equally. Now, if I rounded to 2 decimal places, that's not going to be very helpful. Let's just say we round to 1 significant figure. So over here, if I rounded it to the nearest whole number, that would be 69 point, okay, let's do 1 decimal place. That would be 69.9. This would be 67.2. This would be 70.4. And this would be 67.7. So you can see that we've still got really unequal values. They're not the same. So then what we could try is rounding it to the nearest whole number. So that would be 70. this would be 67, this would be 70, and this would be 68. Again, they don't all round to the same thing. So what I'm going to want to do is round. So this was to 1 decimal place. This was to the nearest whole number or to 2 significant figures. And then I'm going to try to 1 significant figure. So to 1 significant figure, 69 would round to 70. This would round to 70. This would round to 70, and this would round to 70. So I'd say the average speed is 70 kilometers per hour to 1 significant figure, as all of my values round to this. Okay, so in this question, I am given 2 triangles. Neither of them are right angled. So if you don't have a right angled triangle, you know that your options are going to be using the area of a triangle, which is half AB sine C. The sine rule, which is A over sine A, is B over sine B, is C over sine C, or the cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A. And these are written on your formula sheet at the beginning of your exam paper. So if it's a non-right angled triangle, these are the first things that should come to mind. Now I'm told that the area of triangle ADC is 48 centimeters squared. So I know that I can start with using the area of a triangle. So I know that half AB sine C. So I'm going to just quickly label this. I'm going to make this C, because you always label the triangle according to what you want. So you want your angle to be C, so that's going to be C, and these would be the sides A and B. It doesn't matter which one's A and which one's B, because the only important thing is C in this. So half times by 13 times by A times by sine 87 equals 48, because they've told me that the area is 48. So what I can do is just bundle that together. So 0.5 times by 13 times by sine 87 is 6.49109. So 6.4109A is equal to 48. So A is going to be 48 divided by your answer. If you just leave this in your calculator, it remembers the last thing that's in your calculator. So we do 48 divided by answer, which gives me 7.394. So I know that A is 7.394749632. So I know the value of this side here, which is great because I've got 1 step further into my calculation. So 7.39, and the full value's here. I need to work out the length of AB. So I'm then going to look at this triangle here. So what could I do? Well, there's a few things that I could do to help me out. First, I'm probably going to want to work out what this length here is. So AC, I could use the cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A. So this would be my B side, my C side, and I would label this as A. So that would be my little side A. So remember, with the sine and the cosine rule, you can rewrite your triangle however you want. Even though it says that that angle is D, you can relabel it as A, because we're always working with the trigonometric ratios. So I know that A squared is going to be B squared plus C squared, which is 7.39, but you can save that in your calculator, squared, take away 2 times B, which is 13, times by 7.39, times by cos 87. So A squared is going to be 13 squared plus answer squared, take away brackets, 2 times 13 times by answer times by cos 87, and put that all in brackets, and that gives you 213.6200285. So the value of A is going to be the square root of your answer, which is 14.61574591. So I know that this side A, I mean, we've labelled it differently now. Let's just say that's DC, and therefore AC is going to be 14.61574591. Now I've got this triangle here, What's happened there? I don't know. Okay, so now we've got our triangle up here. Now what we could, oh no, not again. Why is the rubber not working? Okay, so what we can do is think about this triangle here. What's happening? We've got 14.61. We've got an angle here, and I'm trying to work out this side here. So let's label that A. This could be big A, this could be B, and this could be big B. So I'm then going to be able to use the sine rule. So A over sine A, which is 52, must be equal to B, 14.61, over sine 112. So therefore A is going to be 14.61 over sine 112 times by sine 52. I'm just rearranging it to work out what the value of A is. So if I type in answer, because it's still got the 14.61 saved, over sine 112, close the brackets. Oh no, it's just deleted itself. Okay, I'm going to have to type it out. So 14.61574591 over sine 112 times by sine 52 equals 12.4218 blah blah blah, and it says give it correct to one decimal place, so that is going to be 12.4. Quite a rushed whistle stop tour of this, but I'm trying to get it done as quickly as possible. It uses all of the 3 further trigonometry formulae, so just make sure you know how to use them. And when you've got a question like this, just think, what is one thing that I can work out? Can I substitute any of these values into the formula? And remember that you can relabel your triangles however you like, as many times as you like. Okay, so here we've got direct and inverse proportion. So just a really quick reminder, with direct proportion, let's say y is directly proportional to x, the formula would be y equals kx. If y was directly proportional to the inverse of x, the formula would be y equals k over x. So hopefully these are things that you already know. If not, then recap on direct and inverse proportion. So I'm told that x is directly proportional to the square of y. The square of y is y squared. So I'm going to write x equals k y squared because I'm using the direct proportion formula. I'm then told that y is inversely proportional, so it's going to be k over something to the cube of z, which is z cubed. So y equals z cubed. So I've just written those out so that I have them. I'm told that z is 2 when x is 8, and I need to find a formula for x in terms of z. So my formula is going to need to be x equals something in terms of z. So I basically want to eliminate y. So let's have a look at what I can do. Well, let's see what happens when I put z equals 2. So I know that y equals k over 2 cubed. So therefore y equals k over 8. So the y value here is k over 8, and there's a y value here which I can eliminate. So what I want to essentially do is put one formula into the other so that I can eliminate the third variable. So we've got x, y and z, but we only want to be writing it in terms of x and z. So I'm going to substitute this into that equation. So x equals k times by y squared. So therefore x is going to equal k times by this, which is k over 8 squared. So let's simplify that. K squared is just going to be k squared, and 8 squared is 64. Imagine this is a fraction, so x is going to be k cubed over 64. And I'm told that when z is 2, when x is 8, so therefore 8 equals k cubed over 64. So therefore k cubed is going to be 64 times by 8, and 64 times by 8 is 512. So to work out what k is, I'm going to need to do the cubed root of 512, and the cubed root of 512 cubed root of, no, that's the 30th root, which is not what I want. Oh my goodness. Okay, the cubed root of 512 is 8. So k is 8. Okay, so I figured out what. Okay, so having not enough space is not helpful, but we've got to the part where k equals 8. So let us rub all of this out. So I know that k is 8 when z is 2 and x is 8. I need to rewrite this formula. So x is k times by y squared. I know that k is 8, and y I know is the same as k over z cubed. And I know that, what's it called? K is 8. So x is going to be 8 times by 8 squared over z to the power of 6, because z cubed times by z cubed, when you multiply indices, you add the powers, so that becomes z to the power of 6. 8 times 8 squared is going to be 512. So your final formula is going to be x equals 512 over z to the power of 6. But this was a very, very difficult one. So just try and find the steps that you can, write the formulas in the way that you can, and try and find how one of them can fit into the other. Okay, so here we've got iteration, and I'm asked to show that an equation has a solution between two values. So a solution is essentially where the graph crosses the x-axis. So I want to show that it crosses the x-axis between 1 and 2. The way I do that is I substitute the values they've given me into the equation. So I'm going to do 3 times by 1 cubed plus 1 minus 11. So 3 times 1 is 3. So I'm left with 3 plus 1 minus 11. 4 minus 11 is minus 7. So when x is 1, y is minus 7. So that point would be over here. I then do the same for 2. So I've got 3 times by 2 cubed plus 2 minus 11. So 3 times 8 is 24 plus 2 minus 11. 26 minus 11 is, oh my goodness, it's been a long day, 15. Okay, so when x is 2, y is positive 15, which would be somewhere over here. So I know that because it's going from minus 7 to 15, the graph, however it looks, it must cross the x-axis between these two values, because one is a negative and the other is a positive. So what you do to show that something has a solution, you substitute the values into the equation. You've got one negative, one positive, and you say, as there is a change in sign, which means it changes from a positive to a negative sign, the solution must lie between these two. Now the next part says show that this equation can be written in the form blah 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 blah. Now all of this is just rearranging equations. That's all you need to do. So let's just think about how we can rearrange this equation. The first step might be to add 11 to both sides. So we add 11 to both sides, so that would be 11. The next step could be to subtract x, so we're left with 11 minus x. The next step would be to divide by 3, so 11 minus x over 3. And the final step would be to cube root it, so the cube root of 11 minus x over 3. So you're just showing the steps that you take in order to get over here. And you know this is your final rearrangement, so just use that and bear that in mind. And the final part is to substitute your values in an iteration formula. Remember, n plus 1 just means the next term. So if x0 is 1.2, x1 would be the n plus 1, and I'd be, oh, that should say xn, that would be the previous term. So I'm going to do the cubed root of 11, take away 1.2 over 3. And that is going to give me 1.4837757766. To work out x2, I substitute this into the formula, so it'll be the cubed root of 11, take away 1.48. What you can do is just put take away answer and divide that by 3. That's going to give you 1.469 313506. And then for the final one, for x3, you're going to do the cubed root of 11 take away 1.469. But again, you can use the answer button on your calculator. Divided by 3 gives you 1.470057458. Now, it asked it to 2 decimal places. So to 2 decimal places, we can see that both of these would round to 1.47. So that is what my estimate for the solution would be. Okay, so in this question, I'm told that George is the manager of a sports club. The Venn diagram gives information about the number of members in the club, where universal set is all members, A is members who play tennis, and B is members who play football. George is going to choose a member at random, and I'm told that given, which is a very important word in probability, that the member plays football. So A is people that play tennis, and B is the people that play football. So given that the member plays football, the probability that they play tennis is 7 out of 15. Okay, so given means that I shrink my universe to just the players that play football. So the players that play football would be made up of 3x plus 4 plus 5x minus 8. So that would be 8x. 4 minus 8 is 4. Okay, so that would be my total. So 8x minus 4 is going to be my denominator. And the probability that the member plays tennis would be 7 over 15. The bit of the overlap, so these are the people that play tennis and football, would be 3x plus 4. So therefore 3x plus 4 over 8x minus 4 must be equal to 7/15. I got 8x minus 4 because I did all of this, added it and simplified, and 3x plus 4 is the intersection, which is the middle bit. I equated it to the probability that they told me, which is 7/15. So now I've got an equation that I can solve. So what I'm going to do is just multiply both sides. So if I multiply by the denominator, I'd be left with 3x plus 4 equals 7, 8x minus 4 over 15. And then I can multiply this side by 15. So 15, 3x plus 4 is equal to 7, 8x minus 4. Let's expand those brackets. So 45x plus 15 times 4 is 60 is equal to 56x minus 28. Now let's simplify. So I'm going to say 60 is 56 take away 45 is, oh my goodness, 11x minus 28. Add 28 to both sides. So 88 is equal to 11x. Therefore, x is equal to 8. So I've formed an equation, solved it to figure out what the value of x is. And then I'm asked to work out the total number of members in the club. Well, the total number of members of the club would be, if I substitute x into all of the expressions. So 6 times 8 minus 14 is 34. 3 times 8 plus 4 is 28. And 5 times 8 minus 8 is 32. Okay, so the total members in the club would be 34 plus 28 plus 32 plus 37. Don't forget the bit outside the Venn diagram. There'll be the members that don't play tennis or football. So add them all together and that gives you 131 members. Okay, so here I've got non-linear simultaneous equations, and that usually occurs when one is a straight line, so in the form y equals mx plus c, and the other one is, well, it could be anything, but it's going to be a quadratic. So L is the straight line with equation y equals x plus 2, and C is the graph with equation y squared equals 6x squared minus 26x plus 29. What you want to do with non-linear simultaneous equations is essentially figure out what one of the variables is and substitute it in. So I know that y equals x plus 2. And here I'm told that y squared equals 6x squared minus 26x plus 29. So what I'm going to do is wherever I see a y, I'm going to substitute x plus 2 instead. So all I've done is I've replaced this with x plus 2 because I know that y equals x plus 2. They are equivalent. So wherever there's a y, I can replace that with x plus 2 because they have the same value. So then I end up with an equation that only has one variable, which will be x or y. So let's expand this. I'm just going to do it quickly because it's late. So x squared plus 4x plus 4, but you can obviously take your time, is 6x squared minus 26x plus 29. Then I'm going to simplify it. So we'll do it bit by bit. So 4x plus 4, I'm going to take x squared from both sides. So that will give me 5x squared minus 26x plus 29. Then I could take 4x from both sides. So minus 26 minus 4 is going to be minus 30. Ooh, I've just moved the square. Sorry, minus 30. X plus 29, and then I'm going to take 4. So 5x squared minus 30x, 29 take away 4 is 25. So then I am just left with a simple quadratic, and whenever you've got a simple quadratic, what you want to do is factorize it. So let's just get rid of all of this and leave this equation over here. So 5x squared minus 30 plus 25 equals 0. Now you can do whatever you want. In order to solve this, you can use the quadratic formula if you want. I'm just going to factorize it using the quadratic method. So I know that 5 times 25 is 125. I need to find two factors that sum to make minus 30. So I know 1 times 125. I know I've got 5 times 25. And actually, okay, that's all the factors I need, because I can see that 5 and 25 could combine to make negative 30. I know that both of, because I've got a negative, both of the values are going to need to be negative, because a negative times by a negative gives you a positive. And they're going to need to add to make, add to make minus 30. Minus 5 minus 25 is minus 30. So I then split them up. So 5x squared minus 5x minus 25x plus 25 equals 0. So all I've done is I've split this thing into two parts, and then I factorize. So 5x would be x minus 1, and then minus 25, well, the common factor would be 25. Yeah, 25. And then x, it would have to be minus 1, because minus times by a minus gives you a positive. So then we combine our brackets, and this is obviously, if you don't know this method, just use the quadratic formula. It's a calculator paper. So you've got 5x minus 25, you combine them. So one bracket is going to be 5x minus 25, the other is going to be x minus 1. We solve it, so we'd say 5x is 25, therefore x is 25 over 5, so x is 5, and x is also 1. So you know that x is 5 and x is 1. Whenever you've got nonlinear simultaneous equations, you're always going to have two coordinates, so 4 answers, 2 x answers, 2 y answers, apart from in like the odd occasional case, but generally in the exams you're going to have 4 answers. So we know that x is 1 and x is 5. So then all we do is we substitute into the easiest equation. So that's going to be y equals x plus 2. So when x is 1, y is 1 plus 2, which is 3. When x is 5, y is 5 plus 2, which is 7. So the coordinates are going to be 1, 3, and 5, 7. Okay, so here you've got the equation of a circle and a tangent. So there's a few things we need to know about this. The first is the equation of the circle is x squared plus y squared equals the radius squared. So in this case, the radius squared is going to be 225, which means that the radius is going to be the square root of 225, and the square root of 225 is 15. So I could just draw a quick sketch of my circle. So I know it's going to be 15, 15, minus 15, minus 15. I'm then told that the point 9, 12 lies on the circle. So 9, 12 would be somewhere roughly here. And the tangent to the circle at P intersects the x-axis at A and the x-axis at B. So it's helpful to just draw like a graph just so you can visualize what's going on. So it's going to touch the x-axis at A. So this would be the point A, and the y-axis would be the point B. I need to work out the area of OAB, where O is the origin, so OAB is this part here. So that is what I'm looking for as my end goal. Oh no, I deleted everything. Okay. Right, so where do we start? Start with the tangent to the circle. So what I can do is, I know what the radius is. I know that the radius is 15. Okay, and I know that a radius and a tangent meet at 90 degrees. Hopefully you know that from circle theorems. But if not, that's fine. Sorry, okay, I've got an extremely bad throat, so hopefully it holds out for the last 3 questions. Okay, so I've been told that P has the coordinates 9, 12, which means that I've got my radius here. I can figure out what the gradient of it is, because I know that the y value is 12. So from 0 to 12, the height would be 12. And the x value, the x value is 9. So the gradient of the radius, I can work out. Gradient is the change in y over the change in x. So the gradient of the radius is 12 over 9. Now I know that a gradient and a tangent are perpendicular to each other, and perpendicular lines have gradients that multiply to make -1. So they're the negative reciprocal of each other. So therefore, the gradient of the tangent is going to be -9 over 12. So reciprocal, you just flip it over. So I've got the first part of my equation of the tangent. So y equals -9 over 12 x plus c. And actually, I could simplify that. -9 over 12, if I divide it by 3, is -3 over 4. So I can just change that to make my calculations a little bit easier. It doesn't matter, you don't need to do that. It's just an option. Okay, so that's the first part of my equation. Now, I also have a coordinate, 9, 12, that I know goes through. So the tangent to the circle at P, I know that this goes through the tangent. So when x is 9, y is 12. So I can substitute that into my equation of the tangent to work out what c is. So 12 equals -3/4 times by 9 plus c. So 12 is going to be -27 over 4 plus c. So c is going to be 12 plus 27 over 4. So let's type that into my calculator. And I get 75 over 4, which is 18.75. So the equation of my tangent, we can write it up here, is y equals -3/4 x plus 18.75. Now the last part of a question like this would be to work out what the coordinates of A and B are. So I know that for A is along the x-axis, so it's when y equals 0, and for B is along the y-axis, so it's going to be when x equals 0. So I substitute that into my formula. So let's start with y equals 0. So 0 is -3/4 x plus 18.75. So -18.75 is -3/4 x, and therefore x is going to be -18.75 divided by -0.75. So type that into your calculator. 18.75 divided by 0.75 is 25. So x is 25. So this here, A is 25. 25, 0. We can write it here as well. Then I do the same for B. So B would be when x equals 0. So y is minus 3/4 times 0 plus 18.75. So therefore y is just 18.75. So that's this over here, 18.75. So B is going to be 0, 18.75. Now I need to work out the area OAB. So just imagine this. It's along the x-axis. So this has a length of 25 and this will have a length of 18.75 because it starts from 0. It's a right angle triangle because you know that this is the origin. So we're just going to do 18.75 times by 25 divided by 2, which gives you 234.375. We don't have units, so we just leave it like that. Apologies for my throat. Okay, so here we've got quite a tricky probability question that involves ratio and forming expressions. So I'm told that a village library contains a total of n books. There are F fiction books, so we've got fiction, 8 history books, which is only 8, and then the rest of the books are science. So everything that's remaining is going to be science, out of a total of n books. So the ratio of fiction to the total amount of books is 2 to 5. So what we could do is just turn that into an algebraic expression just to make our life easier. So that would be 2x to 5x, because we don't know how many books there are. Elon chooses 2 books at random from the library. Find in terms of f an expression for the probability that Elon chooses 2 books of the same type. Okay, so we're going to want to form an algebraic expression. So we know that the total amount of books in the library could be expressed as 5x. We know that the amount of fiction books is 2x. We know the amount of history books is just 8. And we need to create an expression for science. So if the total is 5x and 2x is fiction, we're left with 3x. But we have 8 history books, so science must be 3x minus 8. Okay, so here we've got these expressions. So I'm just going to write them out here. Fiction is 2x, history is 8, science is 3x minus 8, and the total is 5x. Okay, so probability that he chooses 2 books of the same type. Well, if I had a probability tree, remember, let's just give an example with fiction and fiction. So probability of getting a fiction book would be 2x over a total of 5x. But if I've already taken a fiction book, it's going to then be 2x minus 1 out of 5x minus 1 because the book has been taken. So to take 2 fiction books, that's what I do. You've also got 2 science books. So that expression would be 3x minus 8 over 5x, and then 3x. So minus 8 minus 1 is going to be minus 9 over 5x minus 1. And then you've got your history book option. So history would be 8 over 5x for the first book. And for the second book, it would be 8 minus 1, which is 7 over 5x minus 1. So with your probability tree, you multiply to go along the branches, and then you add the events at the end. So we're just going to have some expressions. So for fiction, the probability would be 2x times 2x over 1 over 5x minus 1. I'm just multiplying the fractions together, which would be 4x squared minus 2x over 25x squared minus 5x. Okay, so that's for 2 fiction books. Then we've got science, which would be 3x minus 8, 3x minus 9, 5x and 5x minus 1. So 3x times 3x is 9x squared. 3 times 9 is minus 27x. 8 times 3 is minus 24x, and minus 8 times minus 9 is positive 72 over 25x squared minus 5x. And then you've got your final one, your history, which is 8 times by 7 over 5x minus 1, which is 56 over 25x squared minus 5x. So our final thing that I need to do, they've all got the same denominator, so when fractions have the same denominator, you just add the numerators. So I'm going to add and simplify all of this. So let's just make some space here. So let's simplify. Let's write it all out. 4x squared minus 2x plus 9x squared minus 27x minus 24x plus 72 plus 56 over 25x squared minus 5x. Let's bring all the like terms. 4x squared plus 9x squared would be 13x squared. And then we've got minus 2. Okay, minus 2 minus 27 minus 24 is minus 53x. So that was all of the x terms. And then we've got 72 plus 56, which is 128 over 25x squared minus 5x. Now it's just said find an expression. It hasn't said simplify it, hasn't said write it in its simplest terms. So this is absolutely fine. You don't need to factorize, you don't need to do anything crazy, just leave it like that. The difficulty is knowing how to set up your equation, but they've given either ratio, so use that to turn it into an algebraic expression and work backwards from there. Okay, we made it to the last question, and it's actually, some people might find it easier than the questions that came beforehand. So, a sculpture S is formed from two parts using different materials. The upper part of S has a mass of 144, made from a material with a density of 3.6. So automatically, I'm looking at this, and I know I'm going to need to think that density equals mass over volume. You need to know that formula off by heart, and you need to know how to rearrange it. Told the lower part of S has a mass of this, and the average density of the whole shape is this. I need to calculate the volume of the upper part as a percentage of the total volume. So what I'm going to do, and I recommend you do, is draw yourself a table. Two-way, three-way table. So we've got the upper part, the lower part, and then the total shape. And then we've got density, mass, and volume. Okay, so let's fill in the bits that we know. So I know that for the upper part has a mass of 144 grams, made from a material with a density of 3.6. Lower part has a mass of 1056. And then the average density of the whole shape, so the total shape, sorry, is 5. Okay, great. So now what can I do? Well, because I've got this handy table that I really recommend you use, you could work out what the total mass is. Because remember, when you're working out the total mass, density, anything of a shape, you need to work out, in order to work out the density, you need to know the total mass and the total volume and so forth. So you need to know the total for the shape. So total mass is 144 plus 1056, which is 1200. Now I could work out the volume by rearranging this formula. So volume is going to be mass over density. So I could, what am I trying to do? Volume of the upper part. Okay, so I need to work out the volume of the upper part. So I'm going to do a mass, which is 144 divided by 3.6. So that's 40 centimeters cubed. And then the volume of the total shape will be 1200 divided by 5, which is 240 centimeters cubed. And I need to work out the volume of the upper part as a percentage of the total volume. So it's going to be 40 over 240 times by 100. Type that into your calculator. 40 over 240 is 1/36, times by 100 is 16.6666, going on until infinity. It says give your answer correct to one decimal place, so that is going to be 16.7 centimeters cubed. You know what the volume has to be because they've told you it's centimeters cubed here and here. And that's that question. So hopefully that was helpful. I did make the test a little bit longer just so that I could get as many topics as I could, but hopefully that covers the key things that are going to come up in the paper, and hopefully you found it helpful. Thank you for watching.